Okay, I'm back from lunch. That's good to see. All right, guys, so I know I don't have any numbers on mine, but you should have all the black lines and all the orange lines filled out, right? I think we're at a stopping point with the orange. We're all good. Now we're ready to move into the blue triangle. The blue triangle. Now, do you know which angle I'm focusing here on the blue triangle? What's this tiny one right there? 30. Good, so it's a 30, 60, 90. We're going to focus on the 30-degree side. So what I want you to do is you actually have to trace on this one. So I'd maybe take like a pencil and trace. We are going to put a 30-degree angle in all 4 quadrants. But every time you do that, I need the long leg to be on the x-axis. So when I do my first one, I'm going to put my triangle here. I'm going to make a line essentially between the 0 and the 45. This one, it's not going to be super exact. I just want you to try and make a line tracing essentially. If you line the blue triangle up with the bottom of the X, the bottom of the long leg is on the positive X axis. I want us to make a blue line that's somewhere between, mine is going to be between my black and my orange line. So somewhere right about here. Okay. Just trace it. Now, when I go to put it in my other quadrants, I need that, I need my line to be on that axis again. So every time I trace it, I need my line to be, here, let me draw my first one. Oh, that was a little messy. When I go over to my second quadrant, I'm going to actually flip my triangle over to the backside where I can't see anything. I want my 30-degree angle to be right there at the origin, and I need the long leg to also be along my X axis. This for my second quadrant. So every blue line that I'm drawing is going to be in between the black and the orange line. It's essentially as if I took the orange lines and I kind of like pinched them in a little bit. So let me draw that one. So again, both in the first and the second quadrant, it's in between the black line and the orange line. See that there's kind of like a lot of space up here at the top. We'll fill that in a minute. When I go down to the third quadrant, I want you to flip your triangle upside down. So again, my 30-degree is along by the origin, and the long leg is along the X axis. So again, all my blue lines are going to be in between the orange and the black lines. And then same idea in the fourth quadrant. I'm not only going to turn it backwards, but it's going to go upside down. So I'm essentially taking it how it was on the positive x-axis, and I'm going to flip it down. So again, my blue lines are all between the black and the orange lines. So mine's not perfect, but it should look something like this. There should be a lot of space kind of at the top. There should be a lot of space at the bottom. We're going to put more lines there. It's going to feel really concentrated right along the middle. So all of these lines are between the black ones and the 45-degree ones. I'll put them on my board too. That one's not great, but probably closer like that. So again, the 30-degree lines are as close to the x-axis as we can make them. I know my circle looks a little bit funny, but I've got nothing between the orange line and the vertical lines. Nothing between those yet. That's where my 60s are going to go. All right, let's label all of my lines with the degrees and radians. Anyone have questions on your lines before I start putting degrees and radians there? Okay. So the first one's 30 degrees. So I'm going to write 30 degrees here. And let's figure out how much that is in radians. At least give us a base to work off. So 30 times pi over 180. What goes into both 30, or can 30 go into 180 evenly? Yep, how many times? 6, good. So I can cancel those out, and it's going to be pi over 6. So 30 is the same thing as pi over 6 radians. All of my 30 degrees are gonna be pi over 6, but the coefficient up front is gonna be a little different, okay? Just like when we did our 45, I'm going over here to look at my 30-degree angle in quadrant 2. I'm gonna do 180 minus 30. 180 minus 30 is 150. You guys okay with that? Okay. While we're here, we're going to do the radians as well. So I'm going to do not 180 minus 30, I'm going to do pi minus pi over 6. Or again, if you're like, I hate thinking about those pi's, make it 1 minus 1 over 6. What's 1 minus 1, 6? 5, 6, guys. 5 pi over 6. All right, now we're gonna go the other way. Now we're gonna add 30. So 180 plus 30 is gonna be 210, thank you. And then my radians, instead of minus, we're gonna do plus. So 1 plus 1, 6 is how many 6? 7 pi over 6, good. All right, now for the last one. Now we're not gonna do 180, we're gonna do 360 minus 30. What's 360 minus 30? 330, very good. And then to find my pi, instead of doing 1 minus, we're gonna do 2 minus. 2 pi minus pi over 6. 11. So 2 is the same thing as 12 over 6. So 12 minus 1 is 11. 11 pi over 6. Right. Take a minute, make sure that all of those are right. Now we're going to make our way to the other side of the board to do our sine, cosine, tangent, all that fun stuff. On an adventure. That's good enough. All right, so go over wherever your notes were for this, flip your paper, find that, because now we're going to do 30, 60, 90. And 30 is going to be the angle in the bottom corner. Just like the orange triangle, my blue triangle also has a hypotenuse of 1 unit. So I'm going to label 1 up top there. Now this one, just like the 30, or just like the 45, 45, 90-degree triangle, when we learned this, we had like some X's going on with all the sides. So 45, 45, 90 was X, X, X root 2. Does anyone remember anything about the 30, 60, 90s? Andrew? Very good. X is across from the 30. X root 3 is across from the 60. And then 2x was my hypotenuse. Those were ratios we learned, or those were like, I guess, relationships we learned a while ago. So we're going to keep using them. And I'm going to use that as well as my 1 is my hypotenuse to figure out what these two sides are. So I already know this side is 1, but I'm going to set that equal to 2x in order to figure out what my x, what my 30-degree side is. So 2x equals 1. This is a slightly easier problem than the last one. Just 1/2. Divide by 2. X equals 1/2. So that means my 30-degree side is 1/2. I'm going to put 1/2 inside my box. Now I have to do 1/2 times root 3. What's 1/2 times root 3? We actually can't really make it much simpler. It's just going to be root 3 over 2. Root 3 stays on top, 2 stays in the denominator. Root 3 over 2. Well, x root 3 was like the form. My actual answer is going to be root 3 over 2. So if you want to, while we're thinking about it, if you want to put on your little blue triangle, the bottom leg is that long one, it's √3/2. And the taller, or the tall one, the vertical one is 1/2. So write √3/2 on the bottom leg, write 1/2 on the vertical leg. We're going to use that in a second. But before, just like we did over here, we're going to do sine, cosine, tangent. So I think that's at least a little fun. Sine, cosine, tangent. And again, if you want to remind yourself, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is O, opposite over adjacent. Feel free to add that in. But just like the other two problems, my hypotenuse is still 1. So my opposite is just what my sine is. So my opposite is, oh, I probably should label those. O is my 1/2, A is my √3/2, and H is my 1. What's that?
Why are we going based on 30?
Because right now we're focusing on the 30 because I just drew all my 30s over here. In 1 second, we're going to flip it and do the 60s. Great question. But we're focused on the 30s right now. So sine of 30 is going to be opposite over hypotenuse. Well, opposite is 1/2, hypotenuse is just 1. So my sine is going to be 1/2, just opposite, because anything divided by 1 is itself. Same thing for my cosine. My cosine is just going to be adjacent divided by hypotenuse. So √3/2 divided by 1 is just √3/2. And then last is tangent. This one, again, we're going to have to do a little bit of work. Tangent, and I'm actually probably going to do it over here just because I'm running out of lower board space, but like keep yours in your space on your paper. So I'm going to do opposite, which is 1/2 divided by adjacent, which is √3/2. Whenever we get to a fraction divided by a fraction, we always like panic a little bit. Don't panic too much. We can just think of that as the numerator multiplied by the reciprocal of the denominator, 2/√3. My 2's are going to cancel out, so I get 1/√3. What do I need to do though? I've got one more step before I'm done. Rationalize. √3/3 is my tangent. √3/3 is my tangent. Okay. The reason we did all of this is, and the reason we labeled our little blue triangle is now we're going to go back and do all my ordered pairs. Just like in my 45, 45, 90. Once we wrote my first ordered pair, that's the same ordered pair I use all the way around. Just have some negatives and positives different. So, what is my x value of this 30-degree triangle? What's the x value? It's my horizontal distance. √3/2. So that's what we're going to put for our x's. So our x is going to be √3/2. And then what's our y? What's our vertical distance? 1/2. Good. Every single blue line is going to be √3/2, 1/2, √3/2, 1/2, √3/2, 1/2. But it changes my positive and negatives. And we just reviewed what the positive and negatives should be. So I'll be quiet for a minute. I want you to fill that in around. Take this point and then just make sure the positive and negatives match what quadrant you're in. So when I'm in the second one, negative x, positive y. When we're in the third one, both are negative. And then in the last one, y is negative. And I said I was going to be quiet and I just talked the whole time. My bad. Take a second, make sure you're all cleaned up, ready to go. Have everything filled in. We're ready for the green triangle when you think that you're at a stopping point of the blue. This is the last triangle that we're going to do, the last set of lines. You're probably like, thank goodness, because we are getting a little full up on here, aren't we? When I do the 60-degree lines, I'm gonna, again, always start by putting the bottom of the base of my triangle on the positive x-axis. I want to trace this one as well, because the folding is not gonna work super well. What's gonna happen is you will have your green line will be somewhere between your orange and your black one. Somewhere between your orange and your black one. So just like the 30, I told you we were getting closer to the x-axis. Now we're gonna fill the green line is gonna be in this kind of open space that you have up here. Can you kind of visualize that? I'm gonna do mine in red because I don't have a green marker, but this is the green one. So the 30s really closer to the x-axis, the 60s are closer to the y-axis. My lines aren't perfect or exact, but it should look something along these lines. I'll walk around really quick so you can make sure that your lines are good. If you need help, let me know. And if you have messes up at any point, it's all gonna be okay, but this is the line that the green lines are like. Those are gonna be our 60 degree lines. Yep, yep. This has some nice looking plates in this one. I think Alpha had a little bit of a harder time with it.
I think because it's alpha.
Yeah, we were all struggling.
Sorry.
Yeah.
I'm just gonna roast your alpha files.
Well, I was struggling too. First thing in the morning to do all of this, it's a lot, so. Hopefully if we're struggling, we'll just watch it back. Okay. We ready to do angles in degrees and radians? All right, let's do it. Degrees and radians. So I told you these were our 60-degree lines, so this first one is gonna be 60 degrees. Let's get that in radians. 60 times pi over 180. How many times does 60 go into 180? 3. So all of these are gonna be pi over 3s. When I go to the next one, I wanna, again, I'm always kind of going back to the 180. I'm gonna think about 180 minus 60. What's 180 minus 60?
120.
120, good. I also want to think about it in terms of my fractions to find the radian. We're going to do pi minus 1/3 pi. Or 1 minus 1/3. How many thirds is that?
2/3.
2/3. So we'll say 2 pi over 3. All right, now we're getting into the third quadrant, so we're going to do 180 plus 60, which is 240. And then now if I'm thinking about my radians, we're going to do pi plus 1/3, pi or 1 plus 1/3, which is how many thirds? 4 thirds. Again, all of these have been improper fraction. I do never want a decimal on these. And then the last one, I'm going to think about 360 minus 60. 300. And then 2 pi or 2 minus 1/3.
7/3.
So 2 is 6 divided by 3, right?
Oh.
Minus 1 is going to be 5. 5 pi over 3. Okay. All right, now we're going to jump back over and do our triangle. It's going to be a little bit less work because we've already built our triangle. We're just going to flip it. The blue and the green triangle are basically the same. They're just flipped versions of each other. So we're taking all that we learned from the blue one and just flipping it up to refocus on the green one. So join me on the other board. And erase that. Get ahead of me by labeling, I labeled it 60, 30, 90, so that kind of shifts our focus on what we actually care about. Too many colors. So I try and be a little dramatic with this one to make my short leg on the bottom and my long leg up top. You can redo the math out. You don't have to, and I'm not going to, because it's the same sides as what we just did before, but the side across from 30 is always going to be 1/2. So I'm going to go label the side across from 30, which is now my bottom side. I'm going to label that as 1/2. The side across from 60 is that √3/2, which is now this vertical distance right there. And I am going to do sine, cosine, tangent one more time. Again, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is O over A. Okay. Now, since we have 60 in the bottom left-hand corner, that's the focus of this theta. So that means my opposite now is that √3/2, and my adjacent is the 1/2, and 1 is still my hypotenuse. And we're going to go. Opposite over hypotenuse is √3/2/1, which is just going to be √3/2. Cosine is 1/2 over 1, which is just 1/2. And then tangent, we're going to do a little bit of work, but it's going to be a little bit less work than we did last time. When we do opposite over adjacent, it's going to be √3/2 divided by 1/2. Opposite is √3/2, adjacent is 1/2. When I multiply √3/2 times the reciprocal of 1/2 times 2, my 2's cancel, and I'm just left with √3. And I don't have to rationalize that because there's no denominator, there's no nothing. It's good as it is. Do you notice how my sine and my cosine for my 30 and 60 match? And my cosine and my sine for 30 and 60 also match? Maybe something we're going to explore later. All right, now I think the very last thing we want to do on our unit circle is put our numbers on there. So let's go ahead, put all of our ordered pairs. Oh, I didn't label our our green triangle. Let's do that really quick. What should I have put along the bottom of my green triangle? 1/2. Good. And what should I put along the vertical side? √3/2. Good. That's helpful to me. I wanted to ask that before I started writing, because all of my values are going to be the same. And if my x, my horizontal distance is 1/2, and then my vertical one is at √3/2. Notice that it's, again, just literally the opposite of what we have going on in my 30-60 or my 30 triangle, 30 angles. All right, go ahead and label all your points. Take into consideration the positive and negatives. So as I go to quadrant 2, my x is going to be negative, my y is positive. As I go to my third quadrant, they're both negative. And as I go to my fourth quadrant, x is positive, y is negative. All right, we've got 5 minutes left and we're kind of at the perfect spot. The last thing I really want to tell you, the last thing I want to write on here, I guess there's two things I wanna write. One thing I wanna write is in reference to the angles that we were just learning about. Do you remember how we kept going like from 180, either minusing or adding, and then minusing from 360? You guys remember that? That's what we call bow tie angle. So wherever you were doing your notes before, you can write that. I think if you watched the video yesterday, I mentioned bow tie angles. You also, some people call them butterfly angles. Whatever makes you happy. Essentially, it's the fact that when I draw my angles, I always have to have one leg on the x-axis. So every quadrant you draw in, one leg has to be on the x-axis, and then the right angle is always touching the x-axis. So it looks something like this when you start putting it in all the quadrants. And they can be different sizes, so I'll make that one a little bit different to be dramatic. But if you kind of blend them together, it essentially looks like a bow tie or a butterfly, right? So that's what we call these angles. And then the last piece of knowledge is the most important thing, why we learned everything we learned today. We have X's and Y's up here, right? All of my points are in X's and Y's. The reason that is because that's in reference to two trig functions. Your X is going to give you your cosine, and then the Y is going to give you your sine. So next time I see you tomorrow, we're going to practice, and I'm going to say, what's cosine of pi over 3? What's sine of 225? What's tangent of 120? And you're going to be able to look at this and tell me exactly what those numbers are. Okay? Yes, Ava.
Would you put a video online in case we want to go back and like one?
I'm just recording it right now.
All right.
Any other questions for the good of the group? Okay, let me stop this.